Hi everyone, in this video we're going to learn how to integrate powers of cosine and sine. And this is the first of several videos on this topic, and as you can probably guess from what you see on the screen here, this video will be quite long. Indeed, we're going to see how to take care of the four integrals that you see on the screen here. Now, if ever you want to skip ahead or back to either one of these four integrals, do use the chapters or timestamps that I've added along the timeline. Okay, we're going to start this video by considering even powers, and I'll just write that, even powers of sine and cosine. Once that's done, we're going to be looking into odd powers of cosine and sine. And as we'll be seeing, the parity, so even or odd, makes a difference to the method we'll use to integrate. All that being said, let's get started. So the first one we'll take care of here is the integral of cosine squared of x. And so let me erase everything else on the page here. There we go. To integrate cosine squared of x, we're going to make use of the trigonometric identity for cosine of 2x. Remember, cosine of 2x is equal to cosine squared of x minus sine squared of x. But it's also equal to 2 cosine squared of x minus 1. And it's even equal to 1 minus 2 sine squared of x. And although we don't really need it for integrating even powers of cosine and sine, I'll go ahead and write the second identity that we'll make use of in this video, and that is the Pythagorean identity. So sine squared of x plus cosine squared of x, which is equal to 1. Okay, now that that's out of the way, here's how to take care of this. The problem with cosine squared of x is that technically we're trying to integrate a product of two functions. Indeed, this means cosine of x times cosine of x. And integrating a product of two functions, well, since there's no product rule for integration, we often end up stuck. Luckily though, thanks to the identity we have here for cosine of 2x, we're going to be able to turn any cosine squared of x, or even any sine squared of x, into an expression that we'll be able to integrate involving cosine of 2x. And here's the whole idea. For cosine squared of x, we're going to focus on this second line we have here. And in fact, I'll copy that over here. We're going to use the identity cosine of 2x equals to 2 cosine squared of x minus 1. Now, our goal is to rearrange all of this to make cosine squared of x the subject. So to do that, I'll start by adding 1 to both sides. So I'll have cosine of 2x plus 1 equals to 2 cosine squared of x. And then I'll divide both sides by 2, which I'll write like this. I'll have 1/2 times, in parentheses, cosine of 2x plus 1, which equals to cosine squared of x. And in fact, I'll go ahead and rewrite this from right to left so that it says cosine squared of x equals to 1/2 times, in parentheses, cosine of 2x plus 1. And this is the result we're going to use here. Indeed, going back to our integral here, we can now rewrite this, replacing cosine squared of x by the expression that we have on the right-hand side here. So this will equal to the integral of 1/2 times, in parentheses, cosine of 2x plus 1. Okay, I'll now take this factor of 1/2 outside of the integral, so that it looks like this. I'll have 1/2 times the integral of, in parentheses, cosine of 2x plus 1. And now we can take care of this integral. Indeed, this will equal to 1/2 times, in parentheses, the integral of cosine of 2x, which is 1 over 2 times sine of 2x, plus the integral of 1, which is just x, plus some constant of integration c. And in fact, I'll call it c star, and you'll understand why in a minute. And I close that pair of parentheses. All I have to do now is distribute this half onto each of the three terms that we have inside here. And so we have 1/2 times 1/2 of sine of 2x, so that becomes 1/4 of sine of 2x, plus 1/2 times x plus 1/2 times c star. So that's 1/2 of x plus 1/2 of c star. Finally, rather than having 1/2 times my constant of integration, I'll go ahead and define a new constant of integration as capital C, which equals to 1/2 times C star. And so I can write my final result as 1/4 of sine of 2x plus 1/2 of x plus c. And as such, we're done. We've now integrated cosine squared of x. Okay, now that that's done, let's see how that compares to integrating sine squared of x. And do keep in mind that to integrate this even power, we used the trigonometric identity for cosine of 2x. That being said, let's move on to the next integral. Here we go. We need to integrate sine squared of x. Well, once more, the power that we're dealing with here is an even power. And what that tells us is that we're going to make use of our cosine of 2x identity here. But this time, because we're dealing with sine squared of x, we'll make use of the third line I wrote here, and then I'll copy at the bottom here, the fact that cosine of 2x is equal to 1 minus 2 sine squared of x. And now looking at this result here, the idea is to rearrange this to make sine squared of x the subject. And for that, I'll start by adding 2 sine squared of x and subtracting cosine of 2x from both sides, so that we have 2 sine squared of x equals to 1 minus cosine of 2x. And next, I'll divide both sides by 2 to write sine squared of x is equal to 1/2 times, in parentheses, 1 minus cosine of 2x. There we go. That's our expression for sine squared of x. Using this result, we can go ahead and rewrite our integral as the integral of 1/2 times, in parentheses, 1 minus cosine of 2x. Okay, now I'll take this factor of 1 over 2 outside of the integral, so that this equals to 1/2 of the integral of 1 minus cosine of 2x. And all we have to do now is integrate these two terms. And so we can state that this equals to 1/2 times, in parentheses, the integral of 1, which is just x, minus the integral of cosine of 2x, which is 1/2 of sine of 2x. And of course we'd have some constant of integration, which again I'll call c star. And all we have to do now is distribute this half across this pair of parentheses, which leads to 1/2 of x minus 1/2 of 1/2 of sine 2x, which is 1/4 of sine of 2x. And we'll add to that 1/2 of this constant of integration, which will be 1/2 of c star. And just as I did when we integrated cosine squared of x, I'll go ahead and define a new constant, which I'll call c, which is equal to 1/2 of c star. And so this equals to 1/2 of x minus 1/4 of sine of 2x plus our constant of integration c. And we're done. We've now integrated sine squared of x. And I'll go ahead and box that result. There we go. Okay, now at this stage, we've seen how to integrate both cosine squared of x and sine squared of x. And those were both even powers of sine and cosine. And consequently, for both of them, we used the identity for cosine of 2x. And so now let's move on to odd powers of sine and cosine, in particular powers of 3, to see how to handle that. Here we go. We need to integrate cosine cubed of x. And clearly, when we say cosine cubed of x, we're dealing with an odd power on the cosine. Now, for odd powers of cosine or sine, the method is quite different. And here's the whole idea. I'll go ahead and rewrite this integral as the integral of cosine squared of x times cosine of x, and dx at the end there. And now, although this is in no way an official term or name for this, the cosine that I took out here, well, in my class I call this the tail. And when integrating odd powers of cosine or sine, we'll always take a tail out, just as I did here, and if the tail is a cosine, then we'll need to rewrite the power term we have here as a power of sine. On the other hand, if ever the tail is a sine, then we'll need to rewrite the power term we have here as a power of cosine. And to do that, we'll make use of the Pythagorean identity we have here. Indeed, using this result, we can go ahead and rewrite this cosine squared of x in terms of sine squared of x. And as you no doubt know, all we have to do here is make cosine squared of x the subject in this result. And in doing so, we quickly see that cosine squared of x is equal to 1 minus sine squared of x. And I'll go ahead and box that just as I did in the previous two examples. Now, using this result, we can go ahead and rewrite our integral as the integral of, in parentheses, 1 minus sine squared of x times our tail cosine of x. And now that that's done, in other words, now that we have our tail, which is a cosine, and our power term, which is a sine, we can go ahead and use the method of substitution, more specifically, u substitution. And here's the whole idea. I'll go ahead and define my variable, and I'll say let u equal to sine of x. So I'll quickly write that, let u equal to sine of x, which would mean that du dx, well, that will equal to the derivative of sine of x, which is cosine of x. And as you can no doubt see, that's our tail. So this cosine of x will be du dx, and this sine squared of x, well, that's going to be u squared. And so thanks to this change of variable here, we can rewrite our integral in terms of u, and it becomes the integral of 1 minus u squared times du dx dx. The dx's we have here now cancel each other out, and so we're left with the integral of 1 minus u squared, and we're integrating with respect to u. Now, taking care of this integral, we can quickly write that that's equal to u minus 1/3 of u cubed plus some constant of integration c. And finally, we now rewrite this result in terms of the variable x, using the fact that u is equal to sine of x, so that this becomes sine of x minus 1/3 of sine cubed of x. And of course, we have our constant of integration here. And there we go. We now know how to integrate cosine cubed of x. And I'll go ahead and box that result. There we go. Okay, now remember, to integrate this odd power of cosine, the important initial step was to take this factor cosine of x out of there in order to make our tail. Once that was done, the idea was to rewrite this even power of cosine as a power of sine, so that our tail was simply cosine and our power was a power of sine. That's what allowed us to use u substitution. And to finish this video, let's go ahead and integrate sine cubed of x, for which we'll see that the method is the same. So let's go ahead. Here we have to integrate sine cubed of x. In other words, we're integrating an odd power of sine. And so just as we did for our odd power of cosine, the idea here is to take a factor of sine of x out of this in order to make our tail. And so I'll go ahead and write that that's equal to the integral of sine squared of x times sine of x. Again, what I'm calling the tail here is this sine of x. And here, since our tail is a sine of x, we're going to want to rewrite this sine squared of x in terms of cosine squared of x. And for that, once again, we'll make use of the Pythagorean identity we have here. Indeed, using that, we can quickly state that sine squared of x is equal to 1 minus cosine squared of x. And I'll go ahead and box that result. There we go. So, replacing this sine squared of x by 1 minus cosine squared of x, our integral quickly becomes the integral of 1 minus cosine squared of x times our tail sine of x. And now that our tail is a sine of x and our power is a power of cosine of x, we're ready to use u substitution. And so I'll go ahead and define the new variable u. Let u equal to cosine of x, so that's cosine of x, and so its derivative, du dx, will equal to negative sine of x. And now since du dx equals to negative sine of x, or the opposite of sine of x, the tail we have here, well, that's going to equal to the opposite of, or simply negative, du dx. And since u is equal to cosine of x, this cosine squared of x, well, that's going to be u squared. And so rewriting our integral in terms of the new variable u, this becomes the integral of, in parentheses, 1 minus u squared times negative du dx times dx. Now, the negative we have in front of the du dx can be distributed across this pair of parentheses, so that we have the integral of negative 1 plus u squared du dx and times dx at the end here. And although we don't have to, I'll go ahead and rewrite these two terms in the opposite order so that it says u squared minus 1, and while I'm at it, I'll cancel out these dx's. So this integral is the integral of, in parentheses, u squared minus 1 du. Next, I integrate each of these two terms with respect to u, so this becomes 1/3 of u cubed minus u plus some constant of integration c. And next, to write our final answer in terms of x, we use the fact that each of these u's is equal to cosine of x to state that this equals to 1/3 of cosine cubed of x minus cosine of x plus our constant of integration c. And we're done. We've now integrated sine cubed of x. And I'll go ahead and box that result. There we go. And there we go. That's it for this first video on integrating powers of sine and cosine. And hopefully you can appreciate the distinction that needs to be made between integrating even powers of sine and cosine, for which we made use of our cosine of 2x identity, and integrating odd powers of sine and cosine, for which we made a tail, used the Pythagorean identity, followed by u substitution. There we go, everyone. I really hope that helped, and if it did, please hit like on this video, drop a comment down below, and even subscribe to this channel to help get this video to as many students as possible. All that being said and done, that's it for this tutorial.